Hello guys, welcome back to another video and this is our second lecture for the computer networks, the basics of computer networks. And so as you all know what CICADEX is, I've already told you what is CICADEX. And now today will be, oh wait a sec, what the heck? Okay, yeah. So this is CICADEX.N. As I told you prior, this is a course for computer networks, and this will be freely available on YouTube, and it is part of CICADEX.C, the cybersecurity course of CICADEX, which will be paid, and you can go and get the detailed video on CICADEX.C from our Discord. And yeah, and there also will be a video on YouTube for regarding CICADEX.C, what CICADEX.C is, and explaining everything. So let's move on to today's topic. So today's topic is types of network. Yesterday we discussed what are network, what is computer network, and today we will discuss what are the types of network. Okay, what are the categories of network? Okay, so types of network from this part will be describing you geographical geographical graph of a network, like how we divide a network geographically. Like if you are in your room, then which net what category of your network is. Like if you are in a single room, okay, then the network you're using only in that much area, like 500 square feet. Okay, 500 square feet. So what the kind of network you're using in 500 square feet? What is the category of that network? Okay. And then if you have entire world, okay, entire world, whole peninsulas and all seven continents, okay, then what kind of network is covering a whole world? What is the category of that network? What is that called? Which is also internet. But what is the category of internet? So today we will discuss this, and this is also the part of first module of CICADEX.C, CICADEX.N, first module, network fundamentals. And today we'll be clearing this. And if you don't know me, I'm Zain Archer, founder of CICADEX. And let's move on with today's topic. Okay, so there are many networks in this world. Okay, like first I will tell you the categories of the network. As you can see, L- LAN, WAN, MAN, and PAN. Okay, we'll discuss these furthermore. So, yeah, as I told you, today we'll be going to discuss these network. We'll discuss the network from a spectrum scale, like from smaller network to the bigger network. Okay, as you can see, the PAN is considered the smallest network, then there comes the LAN, then there comes the MAN, then there comes the WAN. Okay, so yeah, think of this as a ladder. We'll start with the smallest, most person network, and then scale the way up to the largest network ever built, the internet. As I told you, internet is the largest, which falls under WAN. Okay, each setup and size introduce new challenge in terms and technology, cost, security, and management. So each of this network, like PAN, LAN, MAN, WAN, have different working criterias, different technologies they use, different topologies they use, and different requirements for the network. And also you can say different maintenance cost of these network. Like PAN has the least maintenance cost, and the security the level of security that you need to provide to a pen is also least. Okay, then this scale will move up ahead when the size of the network will grow. Okay, now let's start with PAN, personal area network. So PAN network is like if you're using Bluetooth, Wi-Fi, like giving Wi-Fi from your phone to your laptop. Okay, connecting your headsets or Bluetooth headsets to your laptop or phone. Okay, like mainly the typical range is 1 to 10 meters, about 30 feet. Okay, this is that is the typical range of a PAN network. It is the smallest network. Okay, like what you can say it properly is when your device is connected to another device under 1 to 10 meters, then what it is a PAN PAN network. Okay, and PAN network, you can also say it as a network which interconnects. A small definition of it is it is which interconnects the two devices in the range of 1 to 10 meters. Okay, it is the same thing that I'm telling, but in different languages. Okay, like a different format, you can say. So a PAN network is PAN is a network for interconnecting devices centered around a single person, as you know. Okay, with the range of few meters. Okay, not a single person. The requirement of single person is not typically, you can say, is not universal. Because if you want to give Wi-Fi to your friend, okay, it is also a PAN. It is also personal area network. It is also considered but the only PAN the requirement of PAN is it should be under this range. Okay, not only single person can use it, but under this range. Okay, then it falls under a PAN, personal area network. Okay, let's so purpose connecting personal devices for convenience, as you know, and technology mainly USB or Bluetooth. These two are the main technologies we use in PAN. Okay, wireless technologies. Common examples connecting a smartphone or car with Bluetooth, blah 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 blah. Smart connecting a smartwatch to your phone is also a really good example of PAN. Okay, wireless keyboards and mouse are also a really good example for the PAN. Let's move on to the next one. LAN, local area network. Okay, it is bigger than PAN, and this covers you can say a room you can say a room a room a single room in which like your home. Okay, LAN is a network that connects devices within a limited geographical area, such as home, office, building, room, school, campus, like that. Okay, if you have a Wi-Fi in this corner of your house, okay, and this is a room, and then it covers whole, what you say, whole full of full house of yours, then that falls under a LAN, local area network. And the thing is that networks will be same. Okay, network is always same. The difference is the size of the network. That's what is different, and that what matters to classify them in PAN, WAN, and LAN. Rest the network works on the same fundamental as I told you in the last lecture. Okay, typical range is like a single building or a small group of buildings. Example, campus, school campus, you can say, or college campus, you can say. Ownership, privately owned and managed by individual organization. Like you can be the owner of PAN, or simply a startup can be the owner of PAN, of LAN. Okay, and same high speed data transfer rates, like you use here in personal area network. Okay, in personal area network, the thing is that you don't need a router to when the router kicks in, then it is no more a personal area network. When a router kicks in, then the smallest network, the smallest network with router a router is a LAN. Okay, the smallest network with a router is a LAN, and the smallest network is PAN. Okay, the smallest network is PAN, but the smallest network with a router is LAN. When a router kicks in, then the smallest network automatically becomes a PAN. Sorry, LAN. Okay, and yeah. So the high speed data transfer rate, it can also be used by wired Ethernet cables, and wirelessly by Wi-Fi, by you can say like radio waves. Wireless access point are the one who transmit these radio waves. WAP. WAP also means web application penetration testing. Okay, so don't get confused in these two terms. Okay, so common example, the network in your home connecting a PC, TV, gaming consoles, and Wi-Fi router, and then the network in office allowing the employees to share files, printers with the help of a router or a switch. You can say a school computer lab. Yeah, these are the examples for LAN. LAN. Okay, what makes a LAN? Okay, a LAN LAN are the workhorse of the networking world. Okay, you can say LAN a LAN. Okay, LAN is the smallest fish in the whole world of networking, computer networks. Okay, if they are high speed. Okay, they are reliable, and yeah, they can be controlled by their owner and pretty easy to use. Okay, they are not as complicated as the other what you can say other types of networks. When we talk about configuring switch and VLANs later in this course, we'll learn about VLANs. Okay, we are talking about managing LANs. Okay, managing like configuring these stuffs, configuring this network. In personal area network, you need no configuration. Okay, you can just open your Bluetooth. Okay, open your Bluetooth and start communicating. But in LAN, when the router kicks in, okay, then you need to configure the router. Okay, then you need to configure the switch. Okay, we'll talk about these hardwares afterwards in this course. Don't worry about that. Sorry for the interruption, guys. Yeah, so we'll talk about these equipments afterwards in this course. But for now, let's talk about the key components. Wait a second. Let's talk about the key components. First is end device. As I told you in the last lecture, PC, laptops, printers, servers, IP and IP phones, like your normal mobile phones, which are having a IP address over the internet. You can also say that, and there are also specific IP phones that are a type of end device. Switches, the central building block of the modern LAN. They are the intelligent for. Okay, we'll talk about switches later in detail. Here it is not mentioned in detail, but yeah, we will. Then there comes the router. Then NIC cards. These are the cards which have your MAC address, and cables. Cables are the yeah, like hardware stuff that you need to build a network on. Okay, let's move to MAN. Okay, Metropolitan Area Network. Okay, this network, as you can see here, this network spreads all around the city. Like it can be you can say it as a network which covers the city or a metropolitan city. Metropolitan city means big cities like Delhi and all those. Okay, a man is a network that spans a physical area larger than LAN but smaller than WAN, because WAN is the biggest network. Okay, wide area network. So internet is the part of internet is a WAN. Like the classification of internet is WAN. Okay, so such as city or large metropolitan areas, as I told you, commonly used by ISPs, internet service providers. Okay, internet service providers use this MAN network to provide what you can say provide LANs to different consumers. Like MAN is made up of different LANs. Okay, this is one LAN, then this is the second LAN, then this is a third LAN, this is a fourth LAN, and combining all these LANs, and there can be more LANs here, small LANs, small local area networks here in this building, in this building, in this building. Multiple LANs. When multiple LANs are combined, then what it makes a man. And man is hard to manage and hard to configure, because uh, man doesn't only includes WAP. What I told you is WAP, wireless access points. It doesn't only include WAPs. It also includes management of wires. Mainly, if you talk about cellular data, okay, it is transmitted from a big wireless access point. There is a big wireless access point, you can see on the towers, which the towers of the any Geo or Airtel. Those are big wireless access points, okay. And so the cellular data is only transferred by wireless access points. So we are not talking about cellular data in wiring and stuff. The wire management comes in when you are distributing routers, okay. When the routers for the LANs are distributed, so then you need to manage wires that are connecting those routers, because the distribution of network without wires on the routers will be nearly impossible, because routers needs high speeds, and high speeds cannot be transferred by radio waves, because these waves are not that much developed yet, so by which we can transfer the data at a much high speed. But the thing is that we can transfer data at high speed with the wires, with the help of the wires. So that's why we need to manage wires and all sort of stuffs in a man network. And we'll go in the details when we'll after completing this course. There will be another second part of second part of the computer networks, which will be paid. So in there we will be discussing in detail about how our ISP works, how to configure our ISP network, and how to do other stuffs. These will be also the part of CICADEX.C. So make sure to check out that one also. And after that, the thing is that when you are configuring a router in a LAN, okay, so it is much more easier to configure the wires in a man network. And yeah, man network, the wireless access point towers for every sim use, you can say, sim sim card, for every sim card to get the cellular data and network, okay. And so these wireless towers are also part of a man. Okay. These are specially made for the users who don't have access to the routers or stuff. So yeah, you can go and use the internet and access the internet from these, what you can say, this man. Okay. But the thing is that when you use this one man, the one with the what do you say, big wireless access points, towers. From now on I will say them just towers, okay. From the big towers, where when you are using this man, then you doesn't fall under a LAN. You doesn't fall here. Where you fall in a PAN, personal area network. Because if you are using cellular data, then for sure you are using a phone or a single laptop, and the range of that Wi-Fi, the hotspot you're giving to your other devices or connecting other devices, will not be more than 30 feet. Okay, so that's why you doesn't fall under a LAN. Okay, next, our man network is yeah, we have got this, and the range is like tens of kilometers. Even tens, sometimes it also increases to the 50s and hundreds of kilometers. Ownership often owned and operated by a single active like government or a ISP. Okay, man is only owned by man is only owned by two peoples. Okay, one can be gov and one can be ISP, your internet service provider. Okay, as you can see, like a government or a large corporation. Large corporation means ISP. Okay, sometimes run by a service provider. Yeah, service provider, internet service provider. Here we are talking about. Technologies often use high capacity fiber optical cables and specialized networking gears. Specialized networking gears means a wireless access point and fiber optic cables to distribute the uh, what you can say, distribute the access of networks in other LAN, smaller LANs. Okay, wait a sec, guys. Let me clean this stuff up really quick. And yeah, talking about the common examples, then the city government connecting the various departments. Yeah, Department of Justice and Department of Security, Department of Homeland Security connecting with each other. That kind of stuff is also, yeah, like that. Police, fire station, administrative tables, like suppose this is a police station, this is Department of Justice, DOJ, then connecting these two, this will require a man. It cannot be done by a LAN. Yeah, TV provider providing high speed internet access to across entire city, as I told you. College university connecting its multiple campus, that I told you, like that. Okay, now let's move on to our next network. WAN, wide area network. So this is the largest network which can ever exist. There can be some more updates if Elon Musk will succeed to take his database to the moon, because he's planning to do so, and he's trying to make a, what you say, station on the moon where he will train his AI bots and make a server, and he's trying to build a type to civilization. So if he will be succeed in this, then we can also get update, and WAN will no longer be the largest network. Then we can also get a galaxy area network or something like that. You know what I'm saying? So yeah, a WAN is a network that spans a larger geographical area, such as a region or a country, even the entire globe, as I told you before. Okay, it is the largest network which is covering the whole world. Internet also falls in this. Key categories: the largest scale of network. Okay, ownership not owned by any single organization. Often, the connectivity is often sold by ISPs. ISPs grant you the lease for connecting to a WAN, the internet, and which are telecom companies. And you also there is a fact that maximum of the maximum of the maximum of the WAN network cables which goes from India to other countries, from the route of Japan, North Korea, and other countries, those are owned by Tata. And you can also say, if the internet will cut off from the world, from the whole world, but India still will be getting the access of internet, because maximum of the optic cables and the access of the WAN is owned by Tata, like not owned by Tata, but yeah, you know what I'm saying. It is not owned by a single person though, because network can only a WAN network cannot be owned by a single person. Okay, a WAN network is a network. Okay, because listen, there is no kind of router in a WAN network. There is no router. It is fully connected to other devices like a server connecting with each other different across the different countries without any specific without any specific what you say any without any specific router connecting with them. They are getting the access of the and internet from the optical cables that they are getting, and that they have been leased. So by that they're getting the access of internet, and they are communicating with each other, okay, over the internet. So it is not owned by anyone. Internet can never be owned by anyone. That's the thing. But the data on the internet, on the servers, can be controlled by many of the peoples. Like if there is a server is owned by a company, and company is owned by a particular person. So that person can make changes to the data. So I never ever trust a web 2, because the manipulation of data can be done by a single person. But if we talk about web 3 and blockchain, it also comes in the internet, but the thing is that the data here is not manipulated by a single person. The access of the data is on the blocks. Okay, each block has access of the data which is uploaded, and the access of each block is owned by every single computer in this world. So nothing is hidden, and no, maximum chances are no one can ever manipulate this data single-handedly. So that's why I never trust Web 2. I only trust Web 3 now. You know what I'm saying? Okay, now let's get in the topic inside. So yeah, yeah. Ownership not owned by a single person. Okay, you can often get access of the WAN by a ISP. Technology relies on complex infrastructure from the service providers, including fiber optic cables, satellite links, and microwave towers. As I told you, radio wave towers, you know, for SIMs. And then common examples, a multinational corporation connecting its office in New York, London, and Tokyo. Okay, that can be example because they are connecting in all over the world, the offices around the world in a single network. Then it will be considered as a WAN. The network of a bank connecting thousands of ATMs and branches across the country. This is also a great example. The internet itself is a ultimate public WAN, as I told you before. So let's move on to the next. Okay, yeah. So the thing is that the ISPs, uh, the ISPs own the stakes in the network. They can never own it fully, but they have some stakes. Every ISP and every big ISP and a telecom company have some stake. So as I told you, a company doesn't run its own fiber optic cable from New York to LA. It pays the ISP, Internet Service Provider, for a dedicated connection, and the thing is that the fiber optic cables are the cables that uh, the internet depends on those cables. Okay, so maximum of the fiber optic cables which are currently those cables are transmit like those cables are transmitted from one country to another by the sea. Okay, those cables are never what you can say them laid like straight on the land. Those are transferred from a ocean. It is the much easier way, and the management of those cables are handled by the companies they are owned by, like Tata. you know Maximum of the fiber optic cables around the world are owned by Tata in the Asian parts. And now WAN connections, WAN types of connection of a WAN, leased lanes, a dedicated private point-to-point connection, expensive but very secure and reliable. Like you will get your own personal optical wire from this point of the world to this point to connect with your what do you say, connect with your other companies. This is leased and uh, okay. MPLS, multiple protocol label switching. We will discuss it in more detail. And A modern technology used by service providers to deliver high performance scalable WANs. The thing is that there are types of routers. Okay, there is one type of router which support MPLS. So what MPLS do is they don't identify they don't identify PC by their the packets by their MAC address or IP address or the data inside. They give them a label like one, and then by finding out this label is one, then they forward it to the next router. They don't look into it, which makes it much more faster. Okay, that's the thing. So like internet-based VPNs, more cost-effective options. Like you use some internet-based VPNs to connect from your company, the headquarter of a company in your country to the headquarter of a company in other country, which is much more reliable, and it is a secure tunnel. It cannot either be, and this tunnel is very hard to track, and yeah, this is what it is. And it connects you on the basis of internet. Like if you want a separate connection, like without connecting yourself to the internet, then you can go with the leased lanes. It's a much better option. Yeah, as I told you, MPLS, multiple protocol label switching. So, multiple protocol label switching, MPLS, is a high performance networking technology used to speed up the flow of data across the large networks, such as those used by internet service provider and the large enterprises. So, what the first point is trying to say is, like, it is a type of tech, which is used by ISPs to fast up the process of data transfer. Okay, instead of using only traditional IP routing, like what routing is, IP routing is, first a packet comes to a router, then it identify its source IP, where it is generated from, and its destination IP, and then it forwards it to the next router. Okay, but the thing is that what here MPLS do is it gives it a label instead of checking source IP and all these stuffs. It gives it a label one. The one label one contains the destination. Okay, so what it do is it just forwards it to the other through the routers, to different routers from each other, until and unless it reaches its destination. Okay, until and unless it reaches its destination, till then they do it, and it is a much more quicker or faster what you can say, faster option to do so. Now let's move on to the role of ISP, the gateway to the world. So, who provides WAN connectivity? It is internet service provider, as I told you, Tata. Reminding you again, maximum of the stakes are owned by them. Maximum of the states of a public WAN, which is internet, are owned by them because they own the maximum of the fiber optic cables. Indirectly, they own the internet. Not, it's not a joke, but yeah, it is. So okay, so we were talking about the gateways, internet service providers. So yeah, Tata owns the maximum of the stakes on the internet because it owns the maximum of the fiber optic cables, which are the basis of internet. So yeah, don't get worry if you are an Indian and you think that internet will be cut off, internet will be shut down for the India, but don't ever think like that because Tata will never let it happen. Okay, next so where? Yeah. So companies like Comet, Virgin, AT&T, Spectrum, these are the main ISPs, which are like these ISPs own the fiber optic cables, most of the fiber optic cables, including Tata. I haven't written it here, but yeah, just telling you. And yeah, those on the fiber optic cables and data centers, the routers. From that, the backbone of the internet. These are the backbone of the internet. So yeah, these are mainly owned by Tata, Spectrum, AT&T, Virgin. Okay, and yeah, for a home user, you pay monthly fees to connect your LAN to the ISP network. For that, for a business, they lease dedicated high performance lanes from a ISP to connect their LANs into a WAN. Okay, so yeah, you got it what I'm saying. The thing is that mainly, if you have a LAN, you pay a monthly fees to your ISP, and that ISP can be a local ISP, which will be using a MAN, so that ISP will pay his ISP, which will be a major ISP, which will be using a WAN. Got it? So that's what a WAN network looks like, and that's how you get your internet to your router. Okay, and you access your internet. So the ISP is the bridge that takes your local traffic and the routers across the globe. Understanding the role of ISP is the fundamental to understanding how data travels long distance. Now like as I told you, as I told you prior, like Pinky and Chinku example I told you, Pinku and Chinky's example I told you, they use the post office to transfer their letters. Okay, so everyone, let's now begin, and let's now we begin and talk about the SAN, storage area network. It is a special case. I will just go through the definitions, and you will know what it is. It is not that important to know. SAN is a dedicated high-speed network that provides access to block level data storage. Like means if you are having a storage, if you are having a server, then you're storing your data here and you're accessing it with your PC. That what is SAN is meant. Okay, it is a private server and you're accessing it by a PC, and that's what SAN is. It's not for the users to browse the web. It is a private network connecting servers to their shared storage pools. This allows for incredible performance, reliability, centralized management, and massive amount of data. As I told you, private network. PC is connecting from the server and accessing the server, accessing the storage inside the server. This is what SAN is. And if you have to go further, then you can connect this server to this server to this server to this server, and these all will be your storages. And yeah, it is really reliable if you want any file in emergency, urgency, and it is really it's quite easy to manage. You can just throw up your files here without any thinking, but you have to organize them if you have to find them quick. So think of a large data center of Netflix videos. Like the thing is that if you're getting a stream, okay, so the thing is that it is not coming directly from the storage area network of Netflix. What what the thing is in what the things in background are going on is, first you are requesting the Netflix website, its web hosting server, to give access to this particular movie. Okay, then what Netflix is requesting his SAN to please give access of this movie to us. Then it is giving the access of the movie to that web hosting server, and then the web hosting server is streaming the movie on your PC or laptop or something like that. You know, And then if we talk about end devices, here's the detail about end devices. End devices are the ultimate source and destination of all data network. As I told you in prior, uh, end devices are those from where the data is generated and from where and the destination of the data. Both are end devices from where data is generated and which is the final destination of the data. Okay, these are called end devices, ultimate source and destination of all networks. These are the devices that humans use in interact with or generate and consume data, part of the service, and they are why the network exists. As I told you, PCs, computers, these are the end devices, and the same thing I told you here. Functions, their function is to create data, as I told you, generation of the data, email you type, and consume the data. The destination one is consuming the data. Example, the video you stream, you are getting a video stream on your YouTube or something like that. That's what it is trying to say. Do this every single To do this, every single end device needs a network interface card, which I told you, MAC, which contains your MAC address, the information of your PC for your private network, and that's NIC card, which NIC card also transmits radio waves into readable data format for your PC, and it also transmits the data coming from the wires to readable format for your PC. That's what NIC card do is. And the details: computer, desktop, laptop, servers, file server, web server, email server, DHCP server, DNS server. DHCP server, which provides IP addresses to the devices on which is part of a network. But nowadays routers are doing the same thing. They provide the IP address on their own. They are working as their own DNS server. Okay, DHCP server and DNS, domain name service, like google.com, like it is the readable format of IP address. That's all you need to know about the DNS server right now at the moment. Phones, printers, smart devices, and IoT devices. These are end devices, as I told you. Now let's move on to the network switch. Network switch. A switch is an intelligent layer 2 device that acts as a central point of connectivity for all devices on the LAN. It is a single most important piece of hardware in the modern wired LAN. What it do is, wait, I will tell you in detail. Let me create a new slide, and let me just delete this one for my convenience. The fuck, man. Delete. Okay. Now let's talk about what we were talking about again. A network switch. 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 Switch is a device. Okay. It is same as hub. Okay. But it is kind of different. Like these are the post ports on the switch. Okay. This port is where the switch is connected from router. These ports by which the end devices will be connected. Okay. So what switch do is it uses a MAC address table. So it gives every single MAC address a number, like blah 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 MAC address, it's number one. Then blah 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 MAC address, it's number two. Then blah 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 MAC address, it's number three. So what switch do is it memorizes this. It memorizes this. What it do is it memorize this switch memorizes this table, and then if a data comes from the third one, the third MAC address, and the destination is for the first MAC address, then what it do is then it will take the data from the third MAC address, it will go to the chart of the MAC address, then it will search for first MAC address, then it will see the first MAC address is on this port, this port. Okay, then it will send the data to this port. Okay, it will not look on the MAC address, it will just check the number and then check on which port I am having this. Okay, like it's on port 1, then it will send it on the port 1. Okay, that's how a switch works. It is a smart hub, you can say, you know. Okay, function. Its primary job is to receive data frames from one device and forward forward them only to the specific destination device. It does it using MAC address table. Okay, how it works, learning this I told you already in the next slide. Okay, as I told you, switch is intelligent. An older device called hub was dumb. Uh, it would simply repeat any incoming signal out of all ports, creating a massive collision. Massive traffic and collision switches haven't have completely replaced the hubs. Okay. Now let's talk about router. Talk about routers. Routers are the switches for your like switch works on a LAN. Okay, routers work on WAN. They connect your WAN to the LAN. They connect your LAN to the WAN. Okay, a router is a layer 3 device which connect different networks together. In the context of a simple LAN, is the most important role is to its most important role is to connect a local area network outside of the world with the wide area network. Okay, as I told you, the internet. So functions router's job is to make decisions about the best path to send the data packets to reach their final destination, which might be another network across the world. So it is trying to say the router will find the best way to connect you to the request that you're making. If you're making a request for a server, for a Netflix server to watch a movie, so it will find the best way to reach the Netflix server, the shortest way. Okay, the shortest way to reach the Netflix server and give you that thing that you're asking. Okay, we'll talk about these in details in further lectures, and the roles for the key roles for the LAN environment. Wait a second, guys. Okay, key roles for the LAN environment is it acts as a gateway. If you want to visit netflix.com or cisco.com, then what it will do, it will the doorway for all traffics leaving the LAN. Yeah, when you go to the Cisco any website, your computer sends a request to the router, and then the router forwards it to the internet. That what it does. Like I told you, it just check for the smallest path and then request the service that you are asking to the server. Path selection, it uses the routing table to determine where to send the packets. It knows that traffic of for a local device stays on the LAN and the traffic for the external address goes to the WAN. So yeah, WAN port. Probably you would have understand that if a router, if you are giving a task to a router to send this packet to a to an end device which is inside the same network, same LAN network, then router knows the difference. It will not send it to the internet. It will directly send it to that IP address inside the LAN. And if you're talking about the what do you say, uh, what it is, yeah. If you're talking about the WAN, how it connects to the WAN and how it checks that it is the smallest part. It have a the router, all routers have a routing table in which the domain names, all the domain names entire this world are noted, and the shortest part of that is noted there, which is controlled by ISPs, and the router make a request to the ISP that I want to visit this blah 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 site. Then ISP gives the shortest part to the router from that routing table. Okay, got it. Next, we are moving towards the network interface card. As I told you, uh, the functions, as I told you prior, what is a network interface card, also known as a network adapter. It is a hardware component, either a physical card or integrated into the motherboard that allows the device to physically connect to the network. As I told you, the ethernet port is your NIC. The ethernet port you use is your NIC. And the function of NIC is the critical translation between the devices and network. Like it translates the data, as I told you prior, that it translates the data, radio waves into data which is readable by a computer, or from the electronic waves to the data which is readable by a computer. Outgoing, it takes the data from the device operating system, encapsulate it into a proper formatted frame, adding MAC address, MAC address. Every NIC has their unique MAC address, and it adds the MAC address, which is the identity of your PC or your end device in in your LAN. Okay, the identity of your uh, LAN in the WAN is the public IP that you have. Okay, formatted the MAC address, error checking info, and converts those digital bits into electrical signals for the copper wire, plus for the fibers that I told you, okay, prior. And incoming, same thing in reverse. So what it do is, the Ethernet first, it will convert data the data zeros and ones into electrical signals, and it will transmit it from the Ethernet port to the wires that are connected in the Ethernet, and then it will give it to the router, and the further process will begin. But if you're talking about the Wi-Fi thing, if then it will convert the zeros and ones into the radio waves, and then it will go ahead. The MAC address, every NIC in the world is permanently assigned a unique MAC address by its manufacturer. This is a physical address of the device on the LAN, and is how the switch knows exactly where to send the frames, as I told you prior. So now, the last thing that we'll learn today is the network medium. The network medium is a physical cable or wire signal that carries the data signals between the devices on the LANs. So network mediums are either the wires, electrical waves, or the radio waves. So what the network medium is, either they are electrical waves or radio waves. So if the data is transmitting from a wire, then the network medium will be electrical waves. Okay, and if it is transmitting wirelessly with a WAP, like wireless access point, then it will be in the form of radio waves. Nowadays, the wireless access point is integrated in your router itself. But before the time, there was a device looking same as the router that comes, and it connects from the router, and it works as a wireless access point for the Wi-Fi. Okay, function to provide the physical pathway to the electrical signals or radio waves that recepts your data. As I told you, common types in the LAN: twisted fiber optic cables, then twisted pair coupled cables, Ethernet. Okay, and then wireless Wi-Fi, as I told you, for the radio waves. Okay, so thank you all, and bye. Zain Archer signing off. Love you all. I'll see you all in the next lecture. And this is it for today. And bye bye.